Antibody drug conjugate. If cancer cell express a specific antigen, then antibody can recognize the antigen. This antibody can be conjugated with an anti-cancer drug. Then this conjugated drug selectively works on cancer cells. This concept is called as ADC, antibody drug conjugate. ADC is composed of antibody, which can recognize the cancer-specific antigen. Also, it has cytotoxic payload, and these two should be connected through chemical linker. Let's look at the mechanism of ADC. If this receptor protein is cancer cell selective antigen, then antibody conjugated with a drug compound can bind to this receptor. And then this complex molecule can be internalized through endocytosis. Once inside the cell, this can form endosome, and drug molecule can be released from antibody by linker cleavage. Or this endosome can be coupled together with the lysosome, and it can form acidic environment of endolysosome. Inside this acidic environment, the antibody molecule can be degraded, and eventually the drug molecule is released into the cytosol. Selecting the right target is the most important first step in ADC. If you want to design anti-cancer drug, cancer-specific antigen would be preferred target. HER2 is one example. In many cancers, HER2 is overexpressed, especially in breast cancers. If the antibody is specifically bound to HER2, only the drug compound can be delivered to breast cancer cell, and those breast cancer cells can be selectively destroyed. There are several linker chemistry strategies. The cleavable linker can be used for conjugating drug into the antibody. So inside the endosome, one approach is a chemical cleavage. Especially endosomes usually becomes acidic environment, and acid catalyzed reaction can cleave the drug molecule from antibody. Another possibility is enzyme cleavage reactions. If this enzyme is selectively expressed in cancer cells, then the enzyme can cleave the drug, and this can provide another layer of selectivity of the drugs. Even without any cleavable linker, the endosome can couple with the lysosome, and this complex make the acidic environment, which can eventually destroy all the antibody structure, and it can release this drug molecule into cytosol. What kind of cancer drugs can be used for ADC? So in this case, we can consider some cytotoxic payload. And these reagents can be topoisomerase 1 inhibitor, or DNA alkylating agent, or microtubule inhibitors. Usually these chemotherapeutic agents can attack the fast-growing any type of cells. That's why if these molecules are coupled together to the specific antibody, these toxic molecules can be transferred only to the cancer cells, so minimizing the cytotoxic effect to other cells. Potentially, it can only attack cancer cells. So this is the concept of an ADC drug. Here is some interesting situation. In solid tumor, there are HER2 positive cancer cells, but at the same time, some cancer cells are HER2 negative, but they exist close enough together. So ADC drug was added. It cannot recognize the HER2 negative cancer cell, but it can bind to HER2 on positive cell and internalized by endocytosis. And in the endosome, it can be enzymatically or chemically, the drug can be released. If this drug has reasonable penetration property, it can be transferred to negative cell, and by this kind of a bystander effect, it can also kill the HER2 negative cancer cell together. Not only antibody drug conjugate, there are several advanced antibody conjugate strategies. So one approach is not directly attached to drug molecule. Cytokine can be attached to antibody. Then antibody can recognize the cancer cell, and this cytokine can activate nearby T cells, and this activated T cell indirectly can attack the cancer cells. Another possibility is not the cytotoxic chemical, degrader conjugate. In this case, PROTAC molecule can be bound to antibody, and then this PROTAC compound is released, and eventually this can attract the E3 ligase and destroy physically the target proteins. This is a PROTAC antibody conjugation system.